Hi everyone, I'm Dr. An. Today I'm so excited to introduce to you the Stable Diffusion, a state-of-the-art deep learning model developed by Stability AI in collaboration with two other institutes to generate digital images from natural language descriptions. One unique feature of Stable Diffusion is that it can run on almost any consumer hardware as long as it's equipped with a modest GPU. It won't have to be the state-of-the-art GPU, won't have to be multiple GPUs because the model is modest in size and doesn't require extensive computational power. And the model was hailed by the PC world as the next killer app for your PC. And the model is well known for its flexibility and versatility of creating photorealistic images. Also, another important feature for Stable Diffusion is that the model is completely open source. You can download the entire model using Hugging Face. You can even change the internal building blocks of the model to make the model more customized to your specific demand. So today, I'm going to introduce you how you can install the Stable Diffusion model in your Colab and then start generating photorealistic images using the model. So to run the model, you have to make sure that you change your runtime to GPU. After that, you can confirm your GPU availability by running the code below. So here, if the GPU is available on your Google Colab, you should see that you have the CUDA version 11. Actually, at the LAION, it uses V100 NVIDIA GPU. And you need to install modules such as diffusers, transformer, and a few other modules. And then you also need to enable widgets in Google Colab so that you can use the notebook login function in Hugging Face so that you can log into your Hugging Face using your token and then be able to download and install the model from the Hugging Face hub. To log into the Hugging Face hub using your own token, you can use the notebook login command. And then it's going to have a pop-up window where you need to provide a token. If you do not have a token or do not have a Hugging Face login password and user name, that you should apply for it first. And if your login is successful, now you are able to import the Stable Diffusion pipeline. As here, I build the Stable Diffusion pipeline because we are going to use the pre-trained Stable Diffusion model. I'm going to use Diffusion model version 1.4. And here, because, well, the Google Colab have limited capacity in terms of the GPU computation and RAM, so therefore, to ensure that the Google Colab can run Stable Diffusion seamlessly, we want to load the weights from the half precision, basically the float 16 instead of the default float 32. And you can use the revision equals FP16 to use half precision. And also, you want to tell the diffusers to expect the weights in float 16 half precision by passing the argument torch dtype equals torch float 16. And then from this step, you have downloaded the model. It takes probably less than a minute to download the model. It's not super large. Because you want to run the pipeline using GPU for faster inference, you want to send the pipeline to CUDA, the NVIDIA GPU provided by Google Colab. And now that started by writing some prompt to generate images with Stable Diffusion. The images will be generated in the pillow image format. So here I'm writing a prompt because, well, I love horror stories. So let's write a prompt regarding a haunted house. The house stood in a dark, misty, mysterious, spooky forest. It stands coiled between trees, and it had minor fragments of glass shattered on ground. And to make sure that the diffusion pipeline uses half precision, we want to import and use the AutoCast module. So here I provided a prompt to the pipe, and then it's going to create a pure image, and then I display and render this image on the Google Colab. And let's take a look of the image created by Stable Diffusion. So this is the image created by Stable Diffusion. It seems to be pretty reasonable. And if you run, so every time, because the model is built on stochastic nature, so every time you run your prompt through the model, it's going to generate a new image. But if you want to generate the very same image, then you should set the seed, the random seed. To set the random seed, you can create a generator, and you manually set the seed to be some number. So it's completely up to you what number you choose. I choose 1, 2, 3, 4. And then I generate the image. And this time, as you can see, the machine generated a different image. But still, I would say this is a pretty good image, really up to my expectation. And so in this case, if you run the following cell again, you are going to get exactly the same image because you have set the random seed. And then if you want to create an even higher quality image, you can play with the num infinite steps, basically referring to the number of infinite steps the model ran in generating the image. So the larger the number you provide, the model is going to take longer and more memory to run. But in general, the image is going to be more realistic than an image that generated using fewer steps. So here I use 500 steps, and as you can see, this image seems more refined than the previous images created. And you can also create many images in one go by supplying the prompt in as a list of descriptions. So here I want to generate a total of 4 images, and I just expand the list to have the same description. A pink pig is jumping to the rainbow 4 times. And then I still provide this list of prompts into the pipeline. And as you can see, we've generated a list of 4 pillow images. And the Stable Diffusion was trained using the image size of 512 times 512. So 512 as the height, as 512 as the width. And later on, I'll show you how you can overturn the default and generate image of a different size. So here, what we want to do is we want to display the 4 images we created in a grid of 2 by 2, 2 rows and 2 columns. We need to create a simple helper function to do that. And here, first, I created a function that can optionally rotate the pure image, because sometimes the image was generated may not be in the same angle as you like. You may want to rotate the image maybe 90 degree or 180 degree. That would allow you to do that. So I put it optional. And what is required is that you want to convert your image, which is the pure image, into a NumPy array, so that later on it can be utilized using the Matplotlib data visualization tool. So here I create a simple pre-processed image function to do the rotation, which is optional, and also converting the image into a NumPy array. And then I create an empty list, and I want to append those transformed images one by one and append them all to this image array list. So as you can see, we processed all 4 images in this list. And then if we take a look of the shape of the first item in the list of image array, we'll see it has a shape of 512 as the height, 512 as the width, and the 3 channels because it's an RGB color image. And now we can start doing the grid plotting. We first define the figure size to be 10, 10. And then I use the image grid function from the MPL toolkits. So this module has already been installed, pre-installed in Google Colab. So you only need to import. I don't think you need to install the module. And then in the image grid function, you need to provide some arguments regarding the figure and what subfigure or axis you want to work with, and also providing the number of rows and columns of axis, basically subfigures that you want to create using image grid. And finally, whether you want any padding between axes. If there's no padding, then the subfigures are going to be clustered together with no interval in between. Otherwise, it's going to provide some padding so that images are separated. And then here I show the images in the grid, and I want to use the image show command from the Matplotlib. And also, I don't want to show any X or Y axis ticks, so therefore I set them to empty. And as you can see, those are the 4 images created by Stable Diffusion. The pink pigs are jumping into the rainbow. And finally, you can also create non-square images. You won't have to use the default 512 times 512. Here, I create a new prompt. 3 white horses with shiny wings are flying above a river. And here, I overran the default image size by suggesting the height to be 512 and also width to be 768. And then this is the image created by Stable Diffusion. Okay, so that's all for today. I hope that you can all enjoy the power of Stable Diffusion and create your own arts. Thank you so much for your attention, and I'll see you next time.